Today I want to dig deep into the new passwordless technology called Passkey authentication. I would expect that many people concerned about privacy would want to know if this technology will be safe. Generally, this technology means that Apple, Google, and Microsoft will be allowing passwordless authentication into their platforms starting this year. So this will be in your face very soon, like in a few months. There are some elements to Passkey tech that raises some red flags, at least from a privacy point of view. Examples are biometrics, Bluetooth use, cross-device tracking, and cloud storage of passkeys. So our task today is to deeply analyze this tech to see if it is dangerous or not. Also, if it is a good solution or just increases the risk of a privacy invasion. As many of you know, I've spoken loudly about the privacy abuse of two-factor authentication and how it was used to track us beyond just performing authentication. Is this new technology going to offer a safer option or not? Stay right there. The passwordless scheme called Passkeys is a standard pushed forward by the FIDO Alliance. This passkey scheme is intended to reduce the friction in the login process by eliminating the use of passwords and the requirement for doing multiple steps like two-factor authentication. I will get into how it works in great detail, but first let's answer this question. Who is in this FIDO Alliance? They're the ones pushing this standard, so it would be important to analyze the motivations of the players by looking at the members. You can see the members of the Alliance are a mixed group. Some represent the big tech players, Google, Apple, and Microsoft. But you will see the financial companies like Amex, MasterCard, Visa, PayPal, banks like Bank of America, US Bank, Wells Fargo, password managers like 1Password, Dashlane, and LastPass, hardware security key makers like Yubico, and hardware manufacturers like Qualcomm, Samsung, in addition to Apple and Google. So it's a mixed group. Just understand that each group has their own motivations. This is important because my concern is if Google can elbow their way in and push anti-privacy objectives into the FIDO Passkey standard. Given the mix of the group and assuming that they get equal votes, then it does not appear that Google can strong-arm the entire group. So let's make a note of that and see it in the actual implementation stage. According to the FIDO Alliance, support for passkeys are now in Apple's iOS 16 and macOS Ventura. However, I do not see anything that indicates it is active. Maybe somebody else knows. Sorry, I hardly use iOS or macOS. Google will be supporting passkeys in October 2023. Microsoft will support it by the end of 2023. No specific time given. So this means this will be front and center very soon. Now initially, these three OS makers will be the first users of passkeys, so likely apps and websites may not be actively using passkeys until next year. At least that's my guess. The point is that this is coming soon, and whether we like it or not, we will be presented with this technology shortly. However, you will be able to stay with a password and 2FA system currently in place. This is an optional feature. They hope, though, that at some point you delete your passwords and rely solely on passkeys. Here's a portion of a video from the FIDO Alliance that allows you to visualize the interface. I will post a link in the description to the original video. But the general interface is that when this is enabled, you will be given an option to set up a passkey instead of using your password. Obviously, you will need to log in with your password the first time. And then the browser will detect that you have a passkey-capable device nearby, meaning a phone, and it will offer you the option for a passkey. When you do, the platform will negotiate with the phone for security credentials, and then you will be asked to confirm using biometrics, whatever your typical login system is with your phone. This could be Face ID, fingerprint, pattern, or PIN, so it doesn't have to be biometrics per se. From then on, you can log into the site using just the phone login and no passwords required. I'm sure this raises a lot of questions, like the safety of biometrics and how this actually works, and how a passkey is sent. And when I first heard it, some parts of it easily made sense, but some got me concerned, so I wanted to learn more. The four concerns about this technology which we will analyze are: number one, biometrics; number two, Bluetooth BLE; number three, cross-device tracking; and number four, passkey credential storage. Let me get into detail about potential threats, if any, in these areas. Number one, biometrics. Some of you don't really understand the issue of biometrics in phone devices. If you think about it, you will not see videos from me criticizing the use of biometrics in phones necessarily. The reason for my ignoring biometrics is that it is not used in the way you think. Phones do not directly send any biometric information to some platform. If they did, I would advise totally against it. Facebook at one point was planning on implementing facial recognition as a sign-in to that platform. And allowing a cloud app to have biometric data directly would be a very big no-no. But maybe my warnings worked because Facebook didn't implement it. Instead, the first use of biometrics was initially in the fingerprint readers of iPhones and later the Face ID in the iPhone. This, of course, is now duplicated in most other phones in some way. There's no need to fear biometrics in phones because the biometrics simply trigger your PIN code. So the biometrics are an indirect method of sending a PIN code. The PIN code is matched to the biometrics, so the final action is just a PIN code. The PIN code on a phone is used to do the device storage encryption, and that is stored only on the phone. Now, the biometric itself is not an actual image of your fingerprint or an actual image of your face stored on the phone that someone can download. It doesn't work like that. For example, the typical fingerprint tech is a capacitance measurement. The sensor contains many capacitors in a grid, and the areas where your skin touches discharges the capacitors, and then the sensor records a value that would be unique to you. There are other methods to measure a fingerprint, like using ultrasound, but the methodology is the same. It is translated to a numeric value. So there is no actual image of a fingerprint. This value then is stored on the phone and used to initiate a PIN code if there's a match. Similarly, the Face ID technology works by creating some sort of measurement of your facial features, and the actual value stored is that measurement rather than the actual face. And both technologies keep that stored value on the phone only. It has to do that, or that's the equivalent of publicly advertising your PIN code. So in general, you do not need to fear device-level biometrics. At the moment, I can generalize by saying that biometrics on phones and laptops are fine. This itself then is not a threat with passkeys. However, be aware that you're not forced to use biometrics. You can use this without biometrics completely, and I will discuss that later in the technical details of the standard. Number two, Bluetooth BLE. As it turns out, the way a device will be detected as having passkey capability will be via hidden communications between devices using Bluetooth BLE. Now, this is interesting in that BLE is a longer range technology than classic Bluetooth. So it did concern me that they are using BLE for this. Classic Bluetooth only has a range of 10 to 15 feet. Usually, BLE can be 200 feet or even more depending on obstructions. I'm going to guess that the reason BLE was used instead of classic Bluetooth is that classic Bluetooth requires pairing. BLE, on the other hand, can be sent without prior negotiation. There just has to be some application that listens. So this means that with the introduction of passkeys, BLE will now be active on all devices, including laptops, desktops, and phones. This could be a future source of concern because of RF detection. At this point, I don't know of a specific threat that this might trigger. Something possible in the future might be that a third party could try to identify devices by triggering a passkey request. I don't know what identifiers are part of the response at this point, so I can't assess the threat accurately. So for the moment, I don't see a current active threat in the initial stages of this, but there's a workaround that I will discuss later once I get into the specifics of how this works, meaning you can work around using Bluetooth. Number 3, cross-device tracking. As some of you know, I've been very loudly complaining about the abuse of 2FA by the likes of Google and Facebook, because these companies use 2FA as a way to do cross-device tracking, meaning they use the phone to confirm your identity. This means that if you're trying to log into a platform with possibly multiple identities for privacy, then that will not work because they match you to your phone for 2FA. They can guarantee your exact location via your phone and guarantee that you're the correct person because the phone identifiers are transmitted to the platform. So even non-logged in interactions on the internet can easily be tracked. My fear is that passkeys, which rely heavily on a mobile phone, would force a clear attachment to the platform and be an even more precise way of 2FA and tracking. But some assurances make me understand that at the very least it is not worse. The credential negotiation between the phone and the other device, let's say a computer, is done via Bluetooth BLE. So it is out of band. It does not use the internet. Now, this does not stop Google from tracking the phone directly using its normal means of cross-device tracking. But the way the FIDO standard operates, the credential negotiation is not connected to Google directly, but peer-to-peer. This way, it works cross-platform. Based on what is described, I would imagine that this would work fine with a de-Googled phone. I'll get into how the technology works in a moment. So to be clear, passkeys do not stop Google in any way from doing cross-device tracking with a normie phone. However, it may eliminate the need for Google to force us to use a specific phone for 2FA, which they do currently. This standard is supposed to work regardless of the device, meaning the standard itself does not require a phone. I would presume that companies like Yubico, makers of YubiKey, will make another type of device that would be a security key for passkey purposes. This would take the passkey away from the phone. I'm looking forward to this option. Passwordless interface but without using a phone. It could be a fingerprint-based device and communicating wirelessly using BLE. This would be a nice privacy-respecting option. So in conclusion, there is a chance that since we do not have to use a phone for a passkey, that there is a privacy benefit. It may also mean that the Google phones would work just as well. And of course, logging into the device that has the passkey does not require Bluetooth at all, and I'll get into the mechanics shortly. Number 4, passkey credential storage. As currently implemented, backup of the passkey credentials, the most important piece being the private key, has to be stored somewhere with a backup. This is in case your device breaks or is stolen. This will be stored automatically at the platform designated storage in the cloud. So Google stores Google phone passkeys. Apple stores Apple passkeys. I guess in iCloud. Microsoft stores Microsoft passkeys. This could change. The FIDO members include the password manager companies like 1Password, Dashlane, and LastPass. I'm sure they'll want to be implementing their own passkey storage methods. Is there a fear with, let's say, Google storing your private keys? The way the standard is defined, the passkey credentials are end-to-end encrypted before they are stored. So it's similar to a master password in a password manager. Thus, my conclusion is that this is not a threat from a cybersecurity point of view. Not sure I want Google, Apple, or Microsoft to know which platforms I'm on though. I look forward to alternate solutions from the password managers. Though mostly those password managers will be concerned about biometric login to the password manager. How it works. The actual logic for how passkeys work is actually very simple and uses proven encryption technology. Instead of using short passwords, which can easily be phished or attacked with brute force, passkeys work by exchanging public key certificates. So your device generates a public-private key pair. The platform also has its private-public key pair. Public-private keys using RSA are very long. It will be a virtual impossibility to break a password in this way. By having access to a public key, each party can send an encrypted message to the other party, and the other party can decrypt the message because they have their own private key. So public keys can be used to encrypt, but only those with a private key can decrypt. This allows a challenge response to be negotiated between the parties. Now, I don't know the actual challenge response used for the passkey technology, but the premise is that some code is sent to the client app. The client app will return the code back correctly, assuming that it decrypted properly. So that's the insurance that it is the valid party. Simple enough. As you can see, no passwords are needed, and the platform just needs the public key and needs to store that instead of a password. The actual credential negotiation is done via a module called WebAuthn, which will be integrated into all the OSs, and a browser will allow interaction to this security module using standard JavaScript. This means that any website could implement passkeys. Now, for non-browser apps and the operating system itself, they rely on a standard called CTAP2. This standard does what WebAuthn does. Well, in fact, I'm sure WebAuthn uses CTAP2 at the operating system level. But CTAP2 allows the actual cross-device communications using BLE, meaning it is the low-level interface used by system apps. I haven't examined the JavaScript code for WebAuthn, but I presume it would be simple enough to implement on any website and thus allow anyone to stop using passwords. Now let's go into the specific hybrid approaches for using passkeys. If you're on the phone and you are connecting to Google on the phone, then you do not need anything special other than to allow the WebAuthn module to pop a phone login when it needs confirmation of a password. As I mentioned earlier, the passwordless confirmation can be a Face ID, fingerprint pattern, or PIN code. All will accomplish the same thing. Since it is the same device, there would be no need for any Bluetooth transmission of any sort. Next scenario, let's say you've logged into Google on your phone, and now you go to your laptop and you want to log into Google on that device. In this case, from your Google ID, Google already knows you've used a passkey before, so it will show you a QR code instead of having you enter a password. You use your registered phone then to scan the QR code, and of course that means sending the response back to Google, and the exchange of the correct code means you have a valid passkey. This action then causes a separate passkey to be created on the laptop, and thus this is an important point. You no longer need the phone to log in, just the biometric sensor on the laptop, either the Face ID or fingerprint as required on the computer. So this is a positive effect on privacy. If you can disassociate a phone from the computer, it is a good thing. The credentials will be done by biometrics alone, and as I discussed, the biometrics just triggers the use of the public-private key. No biometrics are allowed to be exchanged by the different parties. In this example I gave, which used a phone initially, it didn't have to start with a phone. You could have used just the computer to create the passkey. And now you can dump 2FA on the normie phone completely, and now we've disassociated the cross-device tracking. The other option that will become available, as I said earlier, is a security device hardware-based passkey. This will insulate the device from the passkey system. So let's rein this in with a big picture. If you use this as introduced with the usual normie iPhone and Google Android, there is no change to your privacy. You will be spied on like before, and you will be spied on after, meaning there is no loss to big tech's surveillance ability. I'm sure they expect most people to behave in this standard way. Now, the other players in the FIDO Alliance must have pushed for alternate methods. For example, Yubico, which makes YubiKeys, would need alternatives or they would be locked out of the marketplace. This is good because it shows that Google was not able to strong-arm the group. A YubiKey-like device using passkeys will significantly add to privacy. There can't be any cross-device tracking if you choose to have a Google phone with this security key. You can also choose to use passkeys on the laptop instead of phone. We can come back to this as I gain more experience in using this. Generally though, I'm at least happy to say that this technology is not a step backwards in your privacy quest. If you decide to use passkeys, you have certain advantages. First, you dump the aggravating two-factor authentication. Second, it smooths out the user friction with login. And third, it could allow you to dump the phone. Now, it will take years for all sites to be using passkeys, but this will be a big step. This means we are not stuck with being forced to use our phone as our security device and have it physically tied to us and our internet usage. Now, a big caveat, and this is for Linux users. I don't know how long it would take for Linux developers to create the WebAuthn and CTAP2 interfaces. So this is a platform that may have to stick with the usual password methods for a while. Thus, if you're able to use passkeys on your platform, it will be a privacy win. So go for it. Folks, I have privacy products that protect your data so it will not be exposed to any rogue app. We have a Brax2 privacy phone running an open source Brax OS that makes your phone invisible. We also do flashing services to de-Google other phone models on our store, as well as stocking pre-flashed pixels. We have a VPN service, Bytes VPN, which has features like Tor routing, DNS obfuscation, and ad blocking. We have Braxmail, which is a metadata-free way of doing email where no one knows where the message originated from. These products are on my app, BraxMe. Come visit us there. The link is in the description. Thanks for watching, and I'll see you later.